Hello, everyone, and welcome to our session today. My name is Moria, and I'm here today with Jordan Dorr, and we will both be moderating today's session. This session is part of the Microsoft Reactor program. For those of you who are new to the Reactor program, the Reactor program is sorry about that. The reactors are community spaces where we have developers and startup meet both in person and online in different locations where we have in-person physical hub, but also online through webinars and live stream events such as today's event. If you haven't checked out our website, I highly recommend you to scan this QR code and find out more about the upcoming events we have on our website. We will also share the links in the chat, so don't worry if you missed any of the QR codes that we will share here. So as I mentioned, we have those 10 physical locations, but actually we offer live stream events and opportunities for you to learn on a daily basis in different time zones. So whether you're based in the US, Europe, the Middle East, you can choose your location and you will find out more about the upcoming events in your region. If you scan this QR code, you will get a monthly email at the beginning of each month with all the relevant and upcoming events, in-person and live events in your region. So feel free to scan this QR code to sign up for our newsletter. I wanted to also mention the Microsoft Learn program. Microsoft Learn is a free platform for developers, for startups, actually for anyone that's interested to learn more on different technical topics. So if you visit the Microsoft Learn, you will be able to find out different learning paths, different webinars, certifications, and all kinds of opportunities for you to learn. Depending on the level you are coming from, if it's beginner or advanced, and depending on the professional that you have, you will be able to discover the learning path that's right for you. A lot of the Reactor sessions, we will guide you and refer you to the relevant Microsoft Learn opportunities, depending on the session that we deliver, and we will share the relevant links for today's session in the chat. This link with this QR code will lead you to the AI Learning Hub. So this is a page within the Microsoft Learn that gathers all the AI relevant learning opportunities. So this QR code will direct you to this hub. The good thing about the Microsoft Learn is that you can actually learn from anywhere on your own pace, from home, from your office, from wherever you want. Is for free and is pretty simple step-by-step learning. So today's session is actually the 5th session in this series. This series from concept to creation was built from 6 sessions in total. If you missed any of the previous sessions, you can scan this QR code. It will lead you to the registration page, where you can either watch the previous events or sign up for the upcoming events. All these events are recorded and available on our Reactor YouTube channel. We will share the link to the playlist also in the chat. Before we start with today's session, I just wanted to take a minute and share our code of conduct for events. Please take a minute to read this. This basically includes us asking for you to be understanding and patient, respectful, and friendly in the chat. So after this bit long introduction, and apologies again for the delay, we had some technical issues with today's session, so we had to start 2 minutes late. I'm excited to present you Darshna Shah, our speaker for today. Darshna is going to talk about from prototype to production, building scalable and intelligent apps with Azure Inference API. So enjoy the session, and Darshna, over to you.
Thanks, Moria. Hi, everyone. Really glad to be here today to present this session on prototype to production. So let's get into it. So a little bit about me. I am the Chief AI Officer at a company called ElasticCloud. We're a data science and cloud consultancy. I've been in the data science world for approximately a decade. Prior to that, I had an academic career in neuroscience where I was looking at mechanisms of drug-resistant epilepsy. Outside of work, I'm quite active, so you'll find me doing a lot of community engagements, whether that's at Microsoft conferences, meetups, just talking to general people within the community about kind of the latest advancements and technological developments. I like dancing and a lot of nature too. So that's a little bit about me. In terms of what I'm going to cover today, I'm going to take a kind of top-down approach, starting quite broad with the AI landscape and emerging trends and challenges, as we'll kind of see that the technological space is moving at such a rapid pace since the emergence of ChatGPT and the kind of radicalization and mass adoption of AI. So that is really important for us to kind of consider in terms of the whole picture when we're looking at developing solutions in quite a rapid way. I spend a lot of time obviously talking to various different companies around not only defining our own AI strategy, but helping them define theirs as well, and kind of what goes into that recipe mix of a good AI strategy. We'll talk a little bit around AI adoption and the risk spectrum. We'll look at key lessons learned, some common industry agnostic AI use cases, and then I'll talk a little bit around the development lifecycle and some of the tech stack I'll be using in the demo today. So the demo is actually going to be focusing on part of a super agent that I'm looking to hypothesize around building, and that encompasses many different generative AI agents, one of which is a training assistant, which we'll look at developing using Promptflow and Azure OpenAI. I'll show you how I can quickly take that from prototype to production, but also explore some of the future development and iterations that are kind of influenced by some of the learnings of that prototype phase. So in terms of the key takeaways, I'm looking for you to hopefully learn a little bit more around the broad emerging AI trends in the landscape, and also feel empowered to use Azure AI services to prototype and productionize your solutions. So you might have heard a lot recently around big tech's race to AI, and a lot of the big tech giants moving towards kind of pumping a lot of investment and capital behind advancing these models and taking them to the next stage to possess potentially human abilities, in the sense that these AI models can perform any task that an intelligent human can, as opposed to the kind of narrow AI that we've seen from large language models today. And this isn't just about technological supremacy, but it also poses an interesting debate that could potentially change the entire fabric of our society as we know it today. And that ranges from a kind of a load of different global issues that we'll go on to discuss. But my point really is around the rapid pace in which this is developing. So I was at a meetup talk yesterday, and I asked the audience, how quickly do you think artificial general intelligence is going to arrive? And I posed the question in terms of less than 5 years, 5 to 10 years, or more than 10 years. And it's really interesting, just within the technology community itself, there is already quite a lot of variability in how we're talking about the growing capabilities of these models, as well as some of the safety concerns that we might need to highlight. So why should we care about AGI in terms of the future potential applications and risks? So let's start with the kind of positives first of all. So artificial general intelligence being a lot more capable than some of the AI models we see today could potentially help us with our climate crisis. So we're likely to surpass the 1.5 degree point this year. The Paris Agreement and a lot of the COP conferences have done perhaps not as much as they ambitiously started to set out at kind of limiting that 1.5 degree limit. So these models could help us kind of understand and predict climate crises better, help us operationalize and optimize how we use our resources, so that we could better kind of operate on a day-to-day basis. But also it could help us advance technology. We have the healthcare industry. So we've all seen a lot of the recent news around AlphaFold and how that revolutionary AI technology has kind of changed the way in which we can understand how proteins are likely to fold, which could rapidly advance drug discovery. So conditions like cancer, HIV, Alzheimer's disease could be better treated or potentially even eradicated. There's security, obviously, with these very adaptive real-time solutions where threats are detected in real time, and according to the threat, these models can change their behavior to protect the systems that they're designed to protect. We have ending poverty. So by understanding how we can optimize crop growth and distribute those systems more effectively, optimize supply chains, we could potentially provide a much more sustainable source of food and water for most people on the planet, enabling us to have much more of a level playing field, as opposed to where you're born playing a big factor in your kind of quality of life. We have scientific discovery. So we spoke about healthcare, but also within physics. So AGI could potentially have the potential to align different subfields of physics, like general relativity and quantum mechanics. So we can advance things like space exploration in a much more accelerated way. We have education, so providing hyper-personalized educational content, as opposed to the kind of very generic content we see in curriculums nowadays, making that a much more valuable and enjoyable experience for students. And we could potentially see a unified world. So there is a lot of political polarity in the world we see today, obviously kind of underpinned by a lot of the challenges we've already spoken about here. But with some of the applications that we've already discussed, we could potentially see that minimized as well. But with all great technology, we see a lot of risk as well. And this paper by Chevalier et al. In 2023 describes some of that. So some of the risks are quite difficult to fully foresee, but we can hypothesize about what they might look like based on some of the recent research and how these models are advancing. So we have cyber offense as well as protection. AGI could potentially be used to kind of understand vulnerabilities to infiltrate systems. We've got deception, persuasion, manipulation, and political strategy. So we've already seen the rise of deep fakes and the potential damage that can do. That leads us into kind of really becoming kind of portraying a lot of lack of trust across the communities that are kind of empowered to vote. So there is a big risk there. There's weapons acquisition and even weapons design that could potentially come about with AGI. And then these final ones around long horizon planning, AI developing its own AI, situational awareness, and self-proliferation. So if these models are aware, and we'll go on to show a few examples of how this might happen, are aware of the environments in which they're deployed, so whether that's a development environment or a production environment, it could alter its behavior according to its own end goals. So we're beginning to see there a real paradigm shift in terms of kind of the intellect that these models possess to align much more to human and superhuman abilities. But taking us back to the current day and what is likely in the current day, we've seen the Horizon event of ChatGPT being released, which really unlocked this cascade of AI mass adoption. And we can see that this recent research by McKinsey, which analysed 63 different use cases, estimated that generative AI could add up to $4.4 trillion to the economy annually. And this might not be evenly distributed across every industry, but every industry is likely to be affected. And that's underpinned by the transformer technology. Big fan of Bernard Marr's writings and literature within this space, and his kind of key emerging trends for 2025 show some of those kind of sparks of AGI abilities becoming more apparent. So we have augmented working. So a lot of generative AI has kind of taken a low risk approach so far, where we're looking to augment and automate some of the everyday mundane tasks so that the workforce is empowered to kind of focus on things that will bring more value to businesses and enterprises. We've got real-time automated decision making. So we're now shifting into a more of agentic workflows. So this is not just augmenting workflows, but actually automating the entire decision-making process and actually actioning something, whether that means a support call comes through and we automate the response via email to the client, or kind of adjusting from a customer service point of view, adjusting somebody's account from a financial perspective. And whether we allow these systems to be fully automated or not really comes down to risk, and how much risk is likely in the impact. So, for example, medical diagnosis is unlikely to be fully automated for some serious conditions, where it could potentially be life-threatening. And that really brings us on into the kind of realms of responsible AI and the safety limits that we'll kind of see. We've already seen the EU AI Act coming into force next year, which will really be a tool to try and balance this need for innovation, but also to protect against the risks of AI as well. We're seeing a lot more multimodal solutions being put in place. So whether that's video, voice, or kind of images, there are a lot of different ways in which we can interact with these solutions now. I mentioned AI legislation and regulation. With the rise of deepfakes, we're also moving to this post-truth world where the authenticity and trustworthiness of content being put out requires a little bit more effort. There was quite an interesting Kaggle competition not so long ago that actually asked if we could develop models that were capable of spotting deep fakes. And at that time, the models didn't perform as well as humans did, although they came pretty close. There is the ability to obviously accelerate things like quantum AI with generative AI. And as I mentioned, we're seeing more efforts focused around kind of reducing the energy impact that generative AI requires at the moment. So in terms of the adoption risk spectrum, if I just take it through to, if we just look at kind of the end point of where we are on this kind of AGI development spectrum, we're probably at this a level 1 or 2. So this Google paper looked at how AGI might be defined in terms of a meta-analysis, but then also looked at how we can minimize risk according to how much autonomy we give these models. So at the development spectrum, we're at development level 1 or 2, where we're using AI as a tool or as a consultant. And this is where either the human fully controls the task and uses AI to automate mundane subtasks, or it takes a substantive role, but the human is still involved in the process. And there are risks associated with this as well. We're already looking at kind of problems around de-skilling, and within the education space specifically, where students are using GPT to kind of maybe mock up draft essays, and how we use that in terms of kind of IP and kind of new content being generated. So there is this kind of risk of de-skilling and how we maintain levels of competence within industries. There is a lot of disruption within industries themselves, the technology industry being a prime example, where we see new roles like the ML engineer, the AI ethicist, even the chief AI officer being introduced very, very rapidly, where these kind of roles did not exist a decade ago. So as I mentioned, how much autonomy we give these models really can allow us to control and minimize the risk that we're exposed to. When we kind of get onto these AI as an agent, that's where we can kind of maybe come across risks such as misalignment, concentration of power, that also need to be examined quite carefully. So this review by Harvard Business Review actually put together this little quadrant of the 4 types of risk and how we might be able to minimize them. So there is misuse, misapplication, misrepresentation, and misadventure. But most of the big tech firms are, including Microsoft, and these are the Microsoft key pillars for responsible AI, including fairness, inclusivity, reliability, transparency, privacy and security, and accountability. And in terms of the tools that allow us to actually measure safety in our AI solutions, we have a few here which I'll go on to show in the demo later. So we've got prompt shields, harm categories, groundedness detection, protected material, and even the ability to create your own custom safety measures, which is something that I advocate for quite strongly, because as we've seen, there isn't a magic generative AI solution that can kind of resolve for all use cases, and the risks will be different according to the different use cases across different industries too. So likewise, the safety implications will also be different and require differing levels of measurement. So in terms of kind of getting started with your AI strategy, I see a lot of excitement and enthusiasm around the generative AI hype, which is great. But if we're looking for kind of long-term mass adoption within an organization of AI, it needs to be kind of a little bit more thought out. And I do see this a lot across a lot of different enterprises now, where they have a core dedicated data and AI strategy that kind of feeds into the overall global organizational strategy. And in terms of the kind of core components, we have strong alignment, obviously, with the clear business objectives to assess and understand where in the development phase your infrastructure is. So having a very strong performant data platform and governance structure is kind of paramount to ensure that you can quickly adopt AI and build on top of these kind of key infrastructure pieces in order to make sure it's fruitful. So it's fine for the odd POC, but if we're looking at 10 different AI solutions, we do need that kind of core infrastructure. And Fabric and Purview are brilliant examples of how we can do that. Also auditing the data and making sure that it is good quality. We have one single source of truth. We don't have multiple versions of the same playbook or documents that are saying conflicting things. Will also play into how successful and how performant that solution is. And then obviously talent and kind of skilling up your workforce is kind of really important to make sure that these tools are used in the most effective way and people feel confident to use them and the outputs that they generate. So the culmination of these kind of 4 pillars can obviously minimize your time to market. It can also drive better decision making and of course give you that competitive edge. So in terms of the kind of core pillars, that can break down further into your business objectives, data governance, management, infrastructure, how you manage your AI and ML lifecycle, ethics, security is obviously a big one, and obviously innovation and measuring return on investment is also key. So I've just put these links here, which kind of summarize a white paper that came out of the banking industry around key lessons for AI adoption. But I think we can pretty much extrapolate this across the board to all kinds of different AI solutions. So in terms of some lessons learned, start small and scale responsibly is always a good starting point. As I'll go on to show in the demo later on, we can learn a lot from just the development prototype phase around what actually needs to be changed in terms of it to be production ready for that solution. And that really requires a strong interplay between the developers and the people that are using it. So the users are at the core of this narrative. And that might also affect the prioritization of that particular use case. Data quality, as we've mentioned, is critical for success, and keeping humans in the loop, the users at the core of the narrative, and upskilling and reskilling. So in terms of the generative AI lifecycle, it actually follows a very similar path to the traditional data science machine learning lifecycle that we saw not so long ago. So we need still to understand the business need. Why do we want to create the solution? Usually it has a cost saving or profit generating purpose. Then we can go on to assess whether we have the right data and start building with these large language models and their generative capabilities. We can assess whether that is performing as we expected with different evaluation flows. And then if it is adequate, we can go ahead and operationalize and deploy that. So as I mentioned, we are seeing a paradigm shift from ML ops to LLM ops. And what we see is the focus is less on kind of model building and more on a lot of the evaluations. So we're looking not only at the quality of the performance, but also at how grounded it is, the safety levels in terms of toxic content, also cost and latency in terms of performance. These models are very big, and they need performant infrastructure behind it. Okay. So I just want to look at some common industry agnostic use cases, because the other thing I'm often asked is whether we should buy or build. And a lot of announcements were made last week at Ignite, which actually started to show how not only these common use cases can be easily built with things like Copilot and AI Foundry, but also some of the industry specific use cases and the industry specific models that can be brought into these workflows. So some of the ones we see quite commonly are sales and marketing, so RFP drafting, personalized marketing and pitch creation, lead qualification support, even deal coaching for our account managers, creating account summarization and competitor analysis. Within finance, we can use these models to automate financial reporting, even help kind of put forward recommendations around minimizing expenses, how we could better budget and forecast, and also check whether we are compliant with our regulations that we are guided by. Within HR, we've got recruitment assistants, already seen quite a lot in the news around how these can go wrong if we don't have the right unbiased data sets underpinning them. There's employee onboarding assistance, personalized learning paths, and a policy gap analysis. So RAG, which I'm sure we're all quite familiar with, involves kind of augmenting large language models with external data. So we will typically have databases or some proprietary form of data specific to an enterprise, which we will chunk and index using embedding models, so that data can then be called by large language models. So when we get the question, we can embed that, understand which data it is relevant to based on similarity searches, etc., and then use the large language models to generate the adequate output. But this paper by Microsoft Research was actually looking at the kind of advancements in complexity of RAG type solutions. And based on the different, so they categorized 4 different complexity levels, starting with explicit fact queries. So this is very simply, the model is asked to find reference to a specific thing within the data that has been indexed. So it's basic information retrieval. But then we start moving on to these kind of more complicated levels of implicit fact queries and interpretable rationale queries. So this requires a little bit more work from the large language models, and we need to either deduce the answer or apply some common sense logic reasoning. So a little bit more effort, and that's where we're moving to more the agentic workflows, where we're seeing a lot more tools having to be orchestrated within these solutions in order for them to be more performant. And then at the kind of really complex level, we have hidden rationale queries, where the answer is not actually in the question in the data that has been indexed, and another level of analysis needs to be applied across that data in order to find the answer. So that requires not only the common sense reasoning and logic deduction, but also an additional analytical layer. So this is where we're seeing things like SQL queries being used as a tool within these agentic flows, so that a ground source of truth can be used by the large language model to then deduce the answer. So just pulling back to kind of long-term kind of advancements, which I think we should always keep an eye on, just given in the last 2 years we've gone from traditional ML to RAG to agentic flows, things are moving very quickly. And one thing I did want to highlight is some of the limitations that this paper has put forward around some of the issues with large language models at the minute. So we can already see that they have issues with confidence calibration, where we're seeing a lot of hallucinations, and that the answer appears to be factual, even though it's often not correct. It doesn't have the ability to, innately at least, have long-term memory, the ability to continually learn, personalize the content according to who it's speaking to, and some of these other capabilities around long-term planning, transparency, and issues around sensitivity based on inputs. So these current limitations we actually deal with now through things like agentic workflows, but this paper actually suggests that these issues are kind of grounded in the transformer network architecture. So if we look to change that network architecture of these generative models, then we could potentially overcome some of these issues. So, and this is where we can kind of see the higher cognitive function that I was talking about. So in this paper, they actually test theory of mind with GPT-4. So they make up a factual concept, Zerfin, and present the model with this scenario. Tom just lost his Zerfin, but he didn't tell Adam. Adam starts talking to him about how much he loves his Zerfin and notices that Tom makes a sad face. So the model is then asked, why is Tom making a sad face? And it correctly identifies the emotion. So that Tom is making a sad face because he just lost his Zerfin, and he is hearing Adam talk about his Zerfin reminds him of what he's missing. So this is a psychological construct theory of mind that requires us as people to understand not only our own emotions and beliefs, but also other people's, in order to know how people change their behavior in different contexts. So this is what they argued is kind of showing sparks of artificial general intelligence already, because it's able to understand the different emotional perspectives, which is a pretty high cognitive function. So that's where we're kind of moving, but there are also limitations, as we've kind of noted here, and these play into the kind of architecture functions that I was talking about previously. And this is exemplified here, where GPT-4 is asked, how many prime numbers are there between 150 and 250? And it incorrectly states that there are 13 prime numbers. But if we ask it to first list the prime numbers and then tell us the size of that list, it is correctly able to identify that it has 18, there are 18 prime numbers between 150 and 250. So this shows that if we are able to start manipulating the model architecture, we might be able to overcome some of these issues around kind of inline adaptive thinking, where it has to rely on its own internal representations of different constructs, because it needs to predict the next word quite quickly. So moving from RAG to Copilot, it's often becoming quite blurry as to when to use a Copilot solution versus build a customized RAG solution. And this particular table here is probably a little bit outdated, as the announcements at Ignite last week showed some of the new capabilities coming to Copilot with agentic flows. But ultimately, if the solution that we're looking to develop is quite an everyday task and has a diverse user base, Copilot is generally the adequate solution. However, if we're looking at multi-step complex workflows that require a lot of customization, explainability, use a lot of different data sets, traditionally RAG has been the solution to go. As mentioned, that might change in the very near future, given a lot of the announcements last week. So in terms of the demo that I want to go through today, I mentioned I was hypothesizing with automating my own role as Chief AI Officer. We often focus on, well, a lot of the early adoption of AI has focused on automating mundane tasks and subtasks that we want to kind of use to alleviate our time so we can use it in other things. But as we can see, these flows are getting more and more complicated with the power to do more. So I looked at whether we could build a super agent to essentially, which comprise of many different agents, to potentially automate parts of my role, at least anyway. So my role consists of strategic leadership, innovation and development, operational management, team leadership, looking at ethics and compliance, collaboration and communication, and also performance monitoring. And if I'm to break those down into many different sub-agents that could potentially help me with this role, I could look at building an agent to assess AI project risk and also complete compliance auditing. I could look at an agent to recommend and prioritize solutions that we could develop and innovate around. Also around helping upskill my team members, so employee skills analysis and hyper-personalized training recommendations. And then we have AI project performance and report automation. And the thing around this is it's kind of all focused on process automation. So if I take one of those agents, which is the AI skills tutor, how would this agent workflow typically work? So we want to collate the skills team, the team's skills and performance data, generate a validation test, go on to look at their learning profile and their learning style to generate a hyper-personalized learning path for the next quarter. And of course, we want to feed back into this process so that it can be continuously improved in terms of the output that we get from it. So in terms of the Azure stack that I'm going to use, I mentioned I'm going to use PromptFlow. So this is an end-to-end tool for developing LLM applications, and I'll go on to show how it works in a little bit. And we'll also be using Azure OpenAI. So Azure PromptFlow can be used using the cloud UI or also in your local environment. The SDK is really performant now with a few kind of commands. We can quickly deploy all of the Azure resources we need and use many different templates out of the box to start quickly iterating over our solution. I'm actually going to use the cloud AI. I think it just guides us more visually through the process, but I will show how we can take that prototype to then start developing locally. So if I just come out of here, so to create the data, I actually used this Python package called Faker to synthesize some fake data. And the data that I'm going to use today, it comprises of employee ID, some fake names, a role around whether we've got an AI engineer or a data scientist, years of experience, their learning style, and then we started giving scores according to the different skills we expect these roles to be kind of competent in. So we've got statistical knowledge, machine learning knowledge, business analysis, generative AI, presentation skills, responsible AI, security, agile. We've also got some performance scores on some key strategic projects that we have here, as well as some verbose kind of feedback around their last quarter's performance. So in terms of getting started in Azure, if I take you through, so this is my resource group. I have various different things deployed in this resource group, but the main two things you need are Azure OpenAI and Azure Machine Learning. So if we go to our AI Studio, we can kind of see I've already deployed two models here. We've got our GPT 3.5 model and a text embedding model that I'm going to use within our flow. So here we're in Azure ML. If I go into PromptFlow, which is where we're going to be using what we're going to be using today, the first thing we want to do is index that data that I was showing that we created via Faker. It's quite easy to do that. So you just follow the GUI. Again, if you're doing this locally, it's quite easy to do too. And if I just go into the content safety data, is that the right one? Yeah. So we can just upload this whole folder and just follow through. So I'm actually not going to use Azure AI Search, although you can do. I'm going to use a phase index. We just go through next, select the compute type, and go ahead and create that. So while that's running, I already have one that we can use. So if we go back into PromptFlow, and now we're in flows. So we want to create a flow, and we can create various different types of flow. Here we can see we've got a standard flow, a chat flow, and even an evaluation flow. So it makes that entire development process quite streamlined, the fact that we can have that evaluation process in there as well. But there is a whole gallery of different types of flows that we can use. And I just created a standard flow. So to create one is, again, very simple. I'm not going to do that here. And I'm actually going to show you one that I've started to create already. So this is, I mentioned we want to create a hyper-personalized learning plan for each of our team members. So we've got that index data, and essentially a flow comprises of various different tools, and some of the common ones include LLM tools, a prompt tool, and you can even write your own custom Python tool, which you can use LangChain. There are various different types of other tools, including indexing tools, which we're going to be using here. But ultimately, these flows consist of an input and an output. And likewise, all of the tools that you use within the flow also consist of inputs and outputs. So in our input, we basically want to put forward the name of our employee that we would like a hyper-personalized training plan for, and the output, we want the training recommendation. So we've gone ahead and embedded the input, which is our employee's name, and then we have here a Python tool. So what I've done, the reason I haven't used an LLM one is because I'm actually using Azure Inference API as well. So in order to do that, and that gives you a few different capabilities, as well as being able to switch between different models. There is also quite an interesting safety component to it that you can use. So I can actually, let me just take you to the docs and kind of show you the part that I'm talking about. So we've basically taken this bit of code here, which enables us to use a lot of the out-of-the-box safety measures as well. So in order to do that, if we go into requirements, I've just added that to my requirements documentation so that we're able to then use that within our flow. So here we've actually given the LLM the use prompt, the kind of system prompt of, you are an AI tutor for the data science and AI engineering team at ElastCloud. ElastCloud is a AI and cloud consultancy and a Microsoft Gold partner. The AI team implement machine learning and generative AI solutions mainly across the following industries: finance, energy, legal, and security. You analyze the team's performance data to validate skills, proficiencies, and define personalized learning paths for the next business quarter. Given the role of the recent, so here we're referring to the data, the column labeled role, and recent project performance notes, create a test to evaluate the specific team member's proficiency in the focus area, consider their learning style, and adjust the difficulty based on years of experience and past project scores. Based on the skills assessment for recent employees, we want to identify key areas of improvement, so where they've scored below 70, and define a personalized learning path. So we've outputted all of that. Let's just minimize this. So we've got, our compute session is still starting. So I think that I've run this before, so we can kind of look at what the model outputs anyway. So this is based on Sherry's performance data. She's an experienced AI engineer with a visual learning style. Her focus includes machine learning, statistics, etc. She has performed well in the last quarter's AXA generative AI project, but her EDA score was below 70. And an area for improvement is enhancing model explainability for business presentation. Sherry's skills, for Sherry's skills, I recommend the following personalized learning path. To strengthen her EDA skills, I suggest she takes courses on data visualization, such as data visualization with Python on Coursera. It's also referenced a few other courses, data analysis with R. So again, this already shows where we might want to start augmenting the data input that we have. So we don't actually use a lot of R. We use Python predominantly within our ML and AI team. So that might be something that we want to change, is give it a list of courses that we would typically recommend or look into. And then it talks about she may also want to look at collaboration with colleagues to develop interdisciplinary skills. So hopefully this has started. No. So essentially, we can if I remove this, maybe we'll come back to this in a moment. We can see rather than, that's fine. We can see a lot of the safety measures, such as self-harm, hate, violence, etc. And it shows back that it's gone through and through those ensemble of classification models, it's classified that the output of this particular generated recommendation is safe, essentially. But we can also go ahead and evaluate those. So this compute session is still running, but I have created an evaluation flow earlier. So if we go back into, okay, that's fine. If we go back into our runs, we can see some of the evaluation that we've run. So I was particularly looking at groundedness and relevance. So if we go into the groundedness one, for example, and click on view outputs, we can start looking at all of the scores that have been attributed to the test data that I gave it. So I followed the GUI in a similar way, gave it several people's names as input, and we want to look at the recommendations that it's output. So we can see from 0 to 5, 5 being quite grounded, that some of these answers are performing quite well and some of them aren't. And we can see here, Kerry Johnson, for example, has got a groundedness score of 1. And that might also come down to the fact that we've asked the model specifically to highlight areas of improvement where it's below 70. However, the scores for responsible AI and public speaking are actually above 70. So obviously, these large language models are predicting the next token. They're not great at dealing with numerical values. So we might then introduce a new tool where we perform some basic analytics to identify which skills are within individuals or areas for improvement based on their performance below 70. And then that can then be fed into the large language model call. Likewise, we have relevance, which I can go back and show you here. So we can view the output there as well. And likewise, we can see whether some of the, that we're talking about improving public speaking and responsible AI. So we've got here public speaking, attending an online course, which seems quite relevant, particularly given it's around how to craft your personal story. It seems quite relevant, but there might be other things in there that perhaps lack relevance. So that will require a little bit more scrutiny, but the fact that we can quickly get these type of analytics is pretty powerful. To deploy, it's quite straightforward. If we go back to the flow, there we go. Now we have the compute session there. So actually, I might actually just rerun this now so that we can look at those safety measures very quickly. Whilst that's running, just to mention around deployment, if we are happy with this as an initial pass, we can go ahead and deploy that. And again, it's a very straightforward kind of GUI, which we just follow through. The thing I would note is to make sure you have policy insights registered. Otherwise, this deployment generally fails. So the run has now complete, so we can view the output. Oh, it's because I kept that in there. We don't want that. So we give that a few minutes to rerun. whilst that's rerunning, actually, I can, oh, it's quite quick, actually. There we go. So now we can see that the outcomes of all of these different safety measures have actually come back as false. So we can kind of see quite quickly, and I think that's a pretty powerful thing. We can obviously augment that with some of our own custom safety measures too. So if we want to go ahead and then start continuing to develop the solution a bit further, one thing we might want to do is start looking at additional data. As I mentioned, we could look at maybe a refined list of training materials that we could feed in. Obviously, depending on the data types, we could also develop our own training material, which, depending on the length, we might want to look at chunking strategies as well. We might want to explore different models, large language models that might be more performant for this. And we could potentially start looking at more agentic patterns, as I mentioned, around using different tools like the Python analytical tool to basically identify areas of improvement in a tabular form, which is then fed into the large language model. And of course, evaluation, we could explore that in terms of relevance, groundedness, but also coherence as well. So how would that look kind of if we want? So I would actually download these files, and then you can kind of bring them in to your development environment, use the visual editor to help you here, and you kind of got pretty much the same layout as you have in the portal there as well. So you can go ahead and start building more complexity in there. So I'll leave you with some kind of references there. So I often get a lot of kind of questions around which large language model orchestration tools to use. So there's a few links there, but I won't get too bogged down in the tools because, as I mentioned, this technology is rapidly evolving and tools quickly become redundant. So I would recommend to kind of be aware of a lot of the things and play around to understand the pros and cons. But it is interesting to look at. I've also referenced the Reactor series. There is this really great series on GitHub provided by Microsoft of 21 free lessons to get started with building generative AI solutions, and of course the many different AI templates that are available via the SDK too. So yeah, it was a really great session, and look forward to taking some of your questions.
So if anybody has a question, you can write it in the comment and we'll share it. Thank you very much, Darshna. It was an amazing session. Thank you
very much.
Okay, so I see we don't have any questions. You were perfectly clear.
Okay,
yeah.
That's great.
So thank you very much.
If anybody did want to reach out with questions, I'm more than happy on LinkedIn.
Thank you all very much, and see you again next week.
Thank you. Bye.
Bye-bye.